Chapter 6, Lesson 6, Solve Inequalities by Addition or Subtraction. You will be able to solve inequalities by using the addition and subtraction properties of inequality. You can solve inequalities by using the addition property and the subtraction property of inequality. When you add or subtract the same number from each side of an inequality, the inequality remains true. We are going to solve our inequalities the same way we would solve an equation. There's just an added step to graphing. An inequality is a mathematical sentence that compares quantities. Solving an inequality means finding values for the variable that make the inequality true. The table to the right gives some examples of the words you might use when describing different inequalities, and we're going to add to this a little bit as well. So less than, fewer than, that would be graphed with an open circle. The greater than symbol is greater than, is more than, exceeds, also has an open circle. Is less than or equal to, is no more than, is at most, has a closed circle. And is greater than or equal to, is no less than, is at least, is also a closed circle. And this is to graph them. Okay. Solve the following inequalities. Again, we are solving it the same way we would solve an equation. Minus 3, x is greater than 7. That's our solution. So all values greater than 7. Letter B. To get n by itself, we add 5 to both sides. Negative 6 plus 5 is negative 1. Bring down your symbol. Negative 1 is greater than or equal to n, which means our n, our values, are all less than or equal to negative 1. Letter C, to get a by itself, we're going to add 3 to both sides. We get a, bring down your less than symbol, a plus 3 is 11. A is less than 11, so our solution is all values less than 11. Now let's try some with graphing. Still solving it the same way. To get h by itself, we're going to subtract 4 from both sides. 4 minus 4 is 0, so 0 is less than h. Now, 0 is our number that we're using for our solution, so I'm going to put 0 in the center. I'm going to go 1 above 0, which is 1, and 1 below 0, which is negative 1. It is the less than symbol, so I know it's an open circle on 0. Now we need to figure out which way we draw our arrow. In order to do that, pick a number. Either pick 1 or negative 1 and plug it in for our variable. So let's choose 1 and let's see if it works. So I'm going to plug in 1 where the h is. Is 0 less than 1? Yes, it is. This is a true statement. Therefore, 1 is part of our solution. We draw an arrow towards the 1. Let's do another one. Letter E. We're going to add 6 to both sides. We get x is less than or equal to 4. That's our solution. 4 will go in the middle, which means 5 over here and 3 over here. It is less than or equal to, so it is a closed circle. Another way to think of it, to remember if it's open or closed, over here you're only drawing the less than symbol. Here it's less than or equal to. You use more ink to draw this line, so you use more ink for your circle. Nice little trick to remember if it's open or closed. Now pick a number. Pick either 3 or 5 and see which way our arrow goes. Let's choose 5. 5 less than or equal to 4. Is 5 less than or equal to 4? No, it is not. That is false. So 5 is not the answer. Let's make sure 3 is. Let's plug in 3. 3 less than or equal to 4. That's a true statement. So the 3 is part of the solution, and I draw my arrow to the left. Letter F. Minus 1/2 on both sides. And we get 1 and 1/2 greater than A. So 1 and 1/2 goes here, and I'm going to choose 2 and 1 to round up and down. You don't have to count by whole numbers on a number line. You can count. In this case, I did it by halves. So that's perfectly acceptable. It is a greater than symbol, so it is an open circle. Now let's pick something to plug in. Let's pick 1 this time. And remember, we're plugging it in where the variable is. So I'm plugging in 1 here. And then rewrite everything else. And read the statement. 1 and 1/2 is greater than 1. That's true. Because that's true, I'm going to shade the 1. And our arrow goes to the left. Inequalities can be used to represent real-world situations. You will want to first identify a variable to represent the unknown variable. Write and solve an inequality for each situation, then graph the solution. Dylan has $18 to ride go-karts and plays games at the state fair. Suppose the go-karts cost $5.50. Write and solve an inequality to find the most he can spend on games. So our games would be $18. He can spend less than 18. He can also spend 18. So 18 or less means the less than or equal to symbol. Now the go-karts cost $5.50. And we don't know how much he can spend on games. So let's actually define that variable. Let x equal money to play games. So here's our inequality. Now let's solve it. We're going to subtract $5.50 from both sides. Remember, line up those decimal points. The decimal point on 18 is at the end. X less than or equal to, well, this would be 0. Borrow here. Looks like $12.50. So $12.50 is our middle number. And I'm going to upgrade to $13 and also go down to $12. It is a less than or equal to symbol, so it will be a closed circle on the $12.50. And let's plug in one of these numbers, 12 or 13. Let's do 12, and remember you're plugging it in for x. Is 12 less than or equal to $12.50? Yes, it is. 12 is part of my answer, which means my arrow goes to the left. This right here tells me he can spend less than or equal to $12.50 on games. Letter B. An elevator can hold 2,800 pounds or less. Write and solve an inequality that describes how much more weight the elevator can hold if it is currently holding 2,375 pounds. So let's write our let statement. Let x equal, we are talking about how more weight, we're talking about pounds here, so we'll just say pounds. Okay, so we have x amount of pounds plus the 2,375 pounds, which can be less than or equal to 2,800 pounds. That's our inequality. It says it can hold 2,800 or less. So can hold or less. Now let's solve it. Minus 2,375. X less than or equal to this would be 5, 2, and 4. So X is less than or equal to 425 pounds. So 425 would be our center number. So this can be 426, and this can be 424. It is a closed circle. Now let's pick a value to plug in. Let's pick 424. Is 424 less than or equal to 425? It is. So that's part of our solution, which means we shade to the left. We draw a left arrow. Letter C. The high school soccer team can have no more than 26 players. Write and solve an inequality to determine how many more players the team can make the team if the coach already has chosen 17 players. So let X equal players. Now, they can have no more than 26. They can have 26, which means it's an equal to, but they can't have more than that, which means they can have less than or equal to 26. So we have X players plus the 17 already chosen. Let's subtract 17 from both sides. We get X less than or equal to 9. So let's graph 9 in the middle, 10 on the right, 8 on the left. Remember, when you're graphing, it must go in numerical order left to right. So it is a closed circle on 9 because of this bar right here. And let's plug in a value. Let's plug in 8. 8 less than or equal to 9. That is a true statement. 8 is less than 9. So we are going to draw our arrow to the left. Lalo has 1,500 minutes per month on his cell phone plan. How many more minutes can he use if he already has talked for 785 minutes? So let X equal minutes. He already talked 785 plus an additional amount, and he only has 1,500 per month, which means he has to talk less than that 1,500, or he could talk exactly 1,500. So we are going to subtract 785 from both sides. We have 5, 1, and 7. So X is less than or equal to 715. 715 goes in the middle, followed by 716, and after 714. It is a closed circle on 715. And let's plug in a number. I like to do the number on the left first, but it doesn't matter. 714 less than or equal to 715. Again, we have a true statement. So I draw my arrow to the left.